Hi there. Thanks for tuning in. I am Gijs de Groot from UbiOps, and today I'm joined by Joost and Thomas from HKV Lijn in Water. Hi, Joost and Thomas. How are you?
Hi guys, good.
Hi guys.
For those of you who joined the last webinar with Reef Support, welcome back. If this is your first time joining, it's great to have you here. To start off, I'm going to go over the content of this webinar real quick. UbiOps is a powerful AI infrastructure platform that helps to quickly run AI and machine learning workloads as a reliable and secure microservice. In our webinar series, we talk with our users about specific use cases they are working on with our platform. As you can see, today's topic is AI forecasting of solar irradiance for better energy efficiency and usage. In this specific webinar, we'll go over HKV, PTIA, and what they do with their product Raycast, their journey and process with UbiOps, and after this, we'll go into their data journey and how UbiOps has helped them with that journey. Finally, we'll talk about the ambitions with Raycast and reflect on their key takeaways. After that, we'll move on to the audience Q&A. So don't forget that if you think of a question, you can put it in the comment section, and we'll address it during the Q&A part at the end. But to start off, let's start with a quick introduction of our guest. Joost, can you kick us off with a short personal introduction?
Sure, my name is Joost Stanford. I'm working for 6 years now in the field of artificial intelligence, and I'm doing that for HKV, but also for PTIA. I will explain more about that. And well, to me, it's been quite exciting so far because I love to try to think differently to find new solutions in forecasting for water and energy. So.
Okay, thank you. And Thomas?
Yeah, my name is Thomas Stolp. I work at HKV and also at PTIA, and I'm mainly doing development of predictive algorithms, models for the energy sector and for the water sector. And I've been involved in developing Raycast for the last 2 years now. And yeah.
Okay, nice. Thanks. Great to have you here. For everyone in the stream, if you're following along so far, you can let me know by leaving a like, leaving a thumbs up, and let's jump in. So, Joost, can you tell me a little bit about HKV and PTIA and what you're doing with that?
Sure, yes. We are here on behalf of 2 companies today, so HKV and PTIA Energy Intelligence. Let me start with HKV. The company has been working in the field of water for almost 30 years, and traditionally we've always been involved in building models for predicting water levels, weather prediction, determining strength of dikes in the Netherlands, and managing operational water management. And we took on the task of applying artificial intelligence 6 years ago, but then in a responsible and reliable manner. We started in the water sector, but since a few years, we're doing that more and more in the field of renewable energy. And that's where we come to PTIA Energy Intelligence. A few months ago, 3 young and very enthusiastic colleagues started the company PTIA. And we combined actually our knowledge on forecasting with our developments and research in the field of renewable energy, backed up by HKV plus TU Delft to utilize artificial intelligence for risk-based forecasting in the field of energy. And well, what we're talking today, we're building forecasting models for short-term solar irradiation. That's what we are talking about today, but also for load forecasting for renewable energy, volume predictions, etc. That is short, our 2 companies.
Okay. And with those 2 companies, can you tell me a little bit about Raycast and what inspired to develop this solution?
Sure. If you want to go to the next slide, I will start. Why Raycast? Due to the introduction of renewable energy, we are facing new challenges actually in the energy system, but also in energy markets, because it became in some way much more uncertain, especially on the energy production side. With the introduction of renewables like sun and wind, it is harder than ever to exactly predict what the production will be, since we are dependent on the changing weather. And for long-term forecasts like tomorrow or next week, there are many models which are quite good in predicting the weather conditions. Like companies, KNMI is working on that, but also different companies like BioRadar. They can forecast weather pretty well for the coming days. But on the short term, it's a whole different story, because it's hard to build models which are quick enough, but also precise enough for weather prediction for the coming hours. So, and that's where Raycast came in. That's why we built Raycast. And well, if you go to the next slide, I will show you a bit about what Raycast is. With Raycast, we introduced a scalable solution for forecasting solar irradiation for up to 6 hours every 15 minutes. And we deliver the entire country in the Netherlands precise predictions with a resolution of a few kilometers. That's what Raycast is.
Okay. Thank you for the elaboration on that. Now we know that what companies are involved and what products Joost and Thomas are trying to build. I will tell a little bit about UbiOps. UbiOps is a user-friendly serverless inference layer for AI, which helps you to build and run any Python data science task as a scalable API service. UbiOps is use case agnostic, so that means that from use cases like Gen AI and computer vision, but also use cases that we're talking about today, it can be deployed and managed on UbiOps. Next to this, it allows you to process data and files in real time, or async as batch jobs that can run for hours or for days. In this slide, you can see a good representation of our UI and how that looks like. So where does this fit in the AI stack? Well, of course, we know that there are a lot of things involved in developing AI and machine learning, but what we really focus on with the UbiOps platform is the deployment part. So the first part of data management and versioning, data labeling, that is not the core expertise of our platform. It lies mainly in model retraining, model deployment and serving, and workflow management. Next to this, we also allow you to do runtime management and logging, automated dynamic scaling, and managing your resources. So for many AI use cases, you need a lot of compute power. With the UbiOps platform, it's very easy to manage your GPUs and CPUs. It doesn't really matter if they're on-prem or in the cloud. We support hybrid solutions. So that is what UbiOps mainly is for. It's a way to deploy your AI and ML code, and it allows users to really focus on the other parts of the AI lifecycle. So now we know what Raycast and UbiOps is. Let's dive into the journey of Thomas and Joost with Raycast and UbiOps. So my first and foremost question is, what were some of the biggest obstacles or challenges you encountered when deploying machine learning models before utilizing UbiOps?
I think the most important thing for us is that we sometimes feel like we are the champions of prototype building, and making proof of values. But sometimes it's hard for us to take the next step because we don't have that expertise, but we also don't like that part of bringing algorithms in production. So we have strong solutions on the one hand, but cloud development in an efficient way, that's a whole different game for us and a whole different world for us. So it's not our core business. So we had actually the choice, okay, let's hire cloud engineers on one hand, or let's work together with a cloud partner. We could do it ourselves, but that will take us a lot of energy and will take a lot of joy from us as well. So we had to decide, bring our own cloud engineers or find a partner. Well, and that was the moment actually UbiOps came in. And so eventually we made the choice, because it's not our core business to do all those cloud developments. We made the choice to stay focused on the things we are good at, making those algorithms as best as possible, and work together on cloud developments with you guys.
Okay, and how did these challenges impact your ability to innovate and deliver value to your customers?
Well, I think a new thing now with the platform of UbiOps is that for us it's much more convenient to also do iterations within real-time situations. So before we mostly worked or improved our models based on historical data sets, and now we are able, because we are able to implement everything we do, we developed quite fast to do real-time iterations in a way. So to really innovate in the real world instead of in history.
Yeah, and how does that mainly add value for your customers?
Well, what I believe is that the power of artificial intelligence is really in the use of the data. So the value from your algorithm is only visible when you use the data, and you can make so many calculations or reports from historical data, but the data really comes to life when you use the data. And I think for our clients, that's the most important step, to start using the data, and then you can really validate it and become better and improve a lot.
Yeah. Okay. Well, what is also interesting to learn about is how did the actual implementation of UbiOps go for you? And maybe I can ask this question to Thomas. How did you start? How did you get going?
So first of all, we started with splitting our code base into separate deployments, we call them. And that's on the one hand to improve the manageability of the code, but also because we can now scale them individually. And then some algorithms and maybe we may require more resources than others. And in this way, you can scale that individually and also keep the cost relatively low. And on the UbiOps platform, it's also possible to then link these deployments into what's called pipelines. And without showing all details, here you can see a sketch of what our implementation actually looks like. So we get satellite data. We have several algorithms, and then there are some post-processing.
Okay, and can you tell a little bit about those different algorithms? What do they exactly do, or what do they sort of do?
Yeah. So we use satellite data of clouds, and on one hand, we are making nowcast, so short-term forecast of the dynamics and movements of clouds, and also where clouds can appear. And there is a translation of that information to incoming solar radiation on the ground, and that's that are predictions on grid level.
Okay. Well, good that you mention pipelines and that you make use of it. I have a short slide on this specific feature. So as Thomas mentioned, pipelines is one of the important features of UbiOps, which allows users to hook different deployments together. It's one of our most popular features, and it helps standardizing workflows with the selection of predefined functions. They're a great way to optimize your use of compute resources by parallelization, for example. to reduce costs and work in a manageable modular way. It allows you to hook different techniques together. For example, what we see with GenAI is that one deployment is transcribing a live conversation, and in the next deployment, an LLM summarizes that conversation to transcribe the text. On the slide, you can see a nice visual representation of how that would look like. So these squares are deployments, and these are hooked together with different types of business logics. You can even hook up different pipelines to each other. So very useful feature, and great to see that also at HKV you are using it. So now we know a little bit about what you do and how you use UbiOps. It will be great to learn about how do you envision the future for the development of Raycast? What are the goals and what you're working towards?
Yeah, we are. So our pipeline is still in development, and right now we're also working on improving our monitoring as separate deployments or separate pipelines. At the same time, new data is coming available, like every few moments. So we're also looking at automatic retraining after a certain period of time to ensure that our models keep learning from new data that comes available. And at the same time, we also it's also really nice with UbiOps that we can really stay on top of new improvements, and we use CI/CD workflows linked with Git to as we develop, launch new deployments and into production.
Yeah, and I would like to add on that because it's quite like the first steps. You have to learn the platform and put everything in the right pipelines, but now it's quite easy to scale up. So scale up in usage. So for the client side on Raycast, we are validating it at the moment at a few parties, and we are going to expand that later this year.
Yeah. Okay. Very nice. Looking back on the journey to building a successful MLOps or working on building a successful MLOps backbone for your servers, what are some key insights or learnings that you would like to share?
First of all, there is a bit of a learning curve. I think that's normal, but it's relatively short. So once you get the hang of it, it's easy to add complexity to your pipelines and overall design of our system. And another thing key insight for us is we can stay focused on developing better algorithms and keep the design of the cloud infrastructure at the UbiOps platform. So that's I think is great.
Okay. And do you have any advice for companies or startups that are wanting to build a pipeline and are looking into the market for a solution or are considering building it themselves?
Definitely. So on the one hand, just start simple, huh? So add complexity along the way. That's also how we did it. First build a simple main pipeline, and not start with all the more complex things from the start.
Yeah, and also think like you have to question yourself what we really did in the beginning. Is it so the whole cloud development? We asked ourselves, is this something we could do ourselves or we want to do ourselves? Those are different questions, because I think in the end we can do it ourselves, but we experience now that it gives us also a lot of energy just to stay focused on the things we think are important and we like the most. So to me, when I look back on the past half year, I think it's been a good choice for us to work together with this kind of cloud partners. With the main, so there are all technical ways of explaining why that's a good choice. But I think the most important thing for us is that we can stay focused on the things we are good at, and the things we like the most, and that's building the best algorithm. So yeah. That's my advice. So think about what you would like to do and what you're best at, and do that.
Yeah. Sounds very good. Well, those were all the questions that I had for you. Thank you for giving insight in what you're building on and how it's going, and what your advice is for people watching this. I think we can move over to the questions from the audience. I think you can determine amongst yourself who can answer, but we have a question from Nico Koning, who asks, are the AI models also fed with and matched to measurements from the actual grid?
Well, maybe to explain a bit more, we don't forecast any things on the grid itself, but we forecast solar power actually. So like in the whole Netherlands, we deliver pixels for the coming 6 hours with how much solar irradiation there will be, and our clients, they have to we can do that as well, but most clients want to transfer that information themselves to what that means for their operation. So we only use all weather information, different kinds of weather information to calculate the forecast of the solar irradiation for the coming hours. So no actual grid information.
Yes, so another question from Nico. Are there use cases being implemented already that you are working on?
So the last year we have been working closely with one of the grid operators to validate the products and to focus on improving how it should look like, and to validate the quality actually. That's what actually we are finishing now at the moment. In the coming months, there will be a beta version released for the companies who joined us building it over the last year. And in a few months later on, we are trying at the moment to find people who would like to serve as launching customer on the one hand, but also wants to try to learn how raycasts can help them in their operations. So to make it short again, there are use cases now where we are working on implementation of raycast at the moment. Yes.
Yeah. Okay. Well, I don't see any other questions right now. Are there any other people in the webcast that want to ask a question? Right now is the moment. I think I'll give it 1 minute of thinking time. And yes, so I think Nico has all his questions answered. Okay. Then I think we would like to thank you for joining. If you would like to know more about the Raycast solution, or think that Joost and Thomas are working on an interesting solution for your organization or company, I think you can contact them at one of these 3 email addresses. If you would like to, if you're working on AI and deployment and have your models ready, and you want to know more about UbiOps, you can go to our website, www.ubiops.com, or send me an email. We have lots of information on how to start deploying. So I think that's it for today. I would like to thank Thomas and Joost for their time and insight. And
of course.
Maybe, see you another time. Thanks.
Thank you. And I would like to emphasize as a last point that if you have any questions or are just curious about how it works, feel free to contact me. because I like to tell about it. So feel free to contact me.
Okay, nice.